In this video, we're going to be talking about differentiability. Now, this is the process of finding the gradient function, y equals f dash x, and that's called differentiation. Okay, but a function is only differentiable at any point where it is continuous. That is, we can find its gradient at that point. But in order to figure that out, we have to understand what makes something not differentiable. A function is not differentiable at any point where it is discontinuous, where there's a gap or break. So I've got some examples here. Here there's a gap where this asymptote is. So at this point, whatever this point is, we can't actually differentiate this point. We can't find the gradient of this point because, well, it's not there. So that demonstrates that this function is not completely differentiable at all points. Just this point, it's not, a point A. For this one, we've got a gap. We can remember that whenever there's a dot, but it's not colored in, that means it does not include that point. So at point where x is b, we can't find the gradient of that point. And as we can't, that makes it not differentiable. Similarly, when a curve like changes completely, so in this point, it's a graph coming in here, and then it changes to a different curve almost. There's a point where it's not smooth, you could say, and that's where x is equal to c. When x is equal to c in this situation, it's not differentiable. We can't find the gradient of the curve at this point. Okay, so as that's the case, we can kind of come up with a blanket rule, and that is to find the differentiability at a point, a function y equals fx is only differentiable at the point x equals a if its graph is continuous and smooth at that same point at x equals a. So to get this idea completely across, we're going to do just one example. Here it says find all the points where the function below is not differentiable. We can see here that, I'll just circle them. Here it's not continuous and smooth. It's not a smooth curve here. Similarly for this. And it's not continuous here because there's just a gap completely. So those are the 3 points. I'll just really accentuate them here. Those 3 points, they demonstrate where the function is not differentiable. For part B, it says is the function f of x is equal to, and we've got two parts here, x squared for x is greater than or equal to 1, or 3x minus 2 for x is less than 1. Is that differentiable at all points? So there's several ways you can go about this, but even if we don't draw the axes and everything, we can just see that here, x squared, we're going to have a happy parabola at some point, so I'm just going to draw it there. And then here, 3x minus 2, that means we're going to have a straight line coming off it. So as that's the case, you can see already wherever this lies on the axes, that this point here is not smooth or continuous. So as that's the case, it's not differentiable. Left out an E there. Hard word to spell. But the point is not necessarily whether it's differentiable at all, because it is. It's differentiable for all the points here and all the points here. So what is this point where it's not differentiable? And that we know is when x equals 1, because where x equals 1 is where everything starts to change. So it's not differentiable at x equals 1.